In today's lessons, we're going to continue study entity relationship model. So before we continue, I want to kind of have a short discussion of the assignment number 1. So for assignment number 1, yesterday I graded, I think, all the submitted homework. And for the question number 1, I think you all did very well. So you all know how to use or how to calculate the closure of a set of attributes given a set of functional dependencies. So I think I didn't see any problem for the question number 1. For the question number 2, I see a lot of problems. Then I realized that the question actually was missed some information. So the most important information that this question missed is that for the car cell, this relation schema, the primary key should be containing 2 attributes, the car number and service number. So this supposed also be underlined. So unfortunately, this is not underlined. So that's why it's kind of caused confusion, okay? So, but I do see one student did pretty well. So if the salesperson is not underlined according to the assumption that a car may be sold by multiple salespeople, then in this case, sales person number should be multiple. That attribute should be the multiple valued attribute. So if salesperson number can take multiple values for a single car, then this relation schema is not in 1F. It's even not in 1F, okay? Because of multi-valued attribute of the salesperson. So, but I think the question, because the question is given not correctly, so that's why I kind of revise my grade. So pretty much everyone got a full grade. And I think once we finish the ER modeling, then we are going to have the only term exam. So before the term exam, I'm going to give you a review class. So in that review class, we're going to revisit this question, and also we're going to revisit kind of a normalization process. But I do notice that majority of you did pretty well in the normalization process. So you split this car cell into several relation schemas. But I really hope that when you specify the new relation schema, you need to underline the primary key, like what we did in the exercise. That's the first thing you need to notice. You need to underline the primary key for each new relation schema you identified. The second one is that you have to specify the foreign keys and the reference keys. So like what we did in the in-class exercise. But anyway, so I think we were going to review this one before we have the term exam. So hopefully, I hope that you all understand how to do the normalization process. Okay, any questions? So that's for the assignment number 1. Okay, so I kind of revised my grade. So right now, each one of you have a full grade. So because the question number 2 is not correctly given, but we will revisit this question when we do the in-class exercise, review exercise before the term exam. So it should be after next week. I think we're going to finish the ER diagram, ER modeling next week. Okay, any questions? Okay, if no, then let's continue studying the ER model. So I think this is what we got in the last class. Okay, so in the last class, we kind of discuss how to sketch an ER diagram for a given application database. So we know that we are going to use what? Use the rectangle box to represent entity tab, okay? And like employee, department, project, and dependent. So each entity tab should carry a set of attributes, okay? Then the attributes we have to distinguish either attribute is a simple attribute or multi-valued or composite attribute or even complex attribute. So for those attributes, directly connecting to the entity tab and in the single oval and without any subcomponents. So those attributes are called simple attribute, like sex, salary, supervisor, address, and birth date, and SSN department. Then we do model the composite attribute. So composite attribute does have subfields, so we need to show their subfields. So the attribute itself, like name, will connect directly to the entity tab, but the component of name will be connecting to the name. Okay, so in this case, we can hear that name branch out. That means name has subcomponent. So that also indicates name is a composite attribute. For the attributes in the double ovals, that indicate that attribute is a multi-valued attribute. By multi-valued attribute, we mean that, for example, given a department, a specific department, that locations attribute will take more than one values. So that's why that's called multi-valued attribute. So we have locations for the department, location for the project, and so on. And then the last one, if you look at work sum, so work sum is enclosed in the double ovals. That indicate work sum is multi-valued. However, work sum also has subcomponent. So in this case, work sum is a multi-valued composite attribute. So this is actually considered complex. So complex means that the composite attribute nested with multi-valued in any arbitrary order and also to any degree of levels. So in this case, work sum is considered as complex. But anyway, so you need to know, because in the design it's very important. So for example, if you specify locations as multi-valued, so the semantics here will be a little bit different if you specify the locations as single valued attribute. Single valued attribute means that for a given entity, that attribute can only take one value. Multi-values means that for a given entity, that attribute can take more than one value. So that's basically will affect how you're going to design your database when you implement it. So that's why specify the type of attributes is very important, okay? And then we discuss how to kind of model the relationship tab. So we use diamond box. So the relationship tab always connecting to its participating entity tab. I think in the past, I have seen a lot of designs. So basically, those designs are simply connecting to entity tab through a straight line. So that's actually not considered correct. So if you follow the ER model kind of schema, we can never connect to entity tabs directly. We have to connect the two entity tabs through a relationship tab, okay? So for example, managers relate employee and department. Let's actually describe that an employee is a manager of the department, or an employee manages department. Then for the work swap between employee and the department, the semantics here is that an employee works for a department. Okay, then the department controls project, the same thing. So department controls a specific project. So this kind of the more like the first draft of the ER diagram. I think one thing I want to emphasize here is that the supervisor is considered as recursive relationship type because it connects to the employee twice. Okay, so then in order to distinguish how an employee participates in this supervised relationship, we supply the role name for each participation. So if the employee participates through the left side or left leg, that means that that employee is a supervisee. If an employee participates through this right leg or on the right side, that means that that employee is a supervisor. So these role names are very important to distinguish the roles that employee participate in this relationship. So this supervisor is called recursive relationship type. Okay. Another thing I think we can introduce is called the degree of a relationship type. So each relationship type has a degree. Okay. So the degree is simply kind of specified by the number of the connections from the relationship type. For example, for the managers, it has two connections, one to the employee, one to the department. So the manager's degree will be 2, okay? And the works for the same. So works for connecting to the employee and department. So it has 2 legs connecting to different entity types or even the same entity type. So that means works for is the degree is 2. So I think for the entity type, when we measure the degree of an entity type, we simply count the legs branching out of that relationship type. So if we see all the relationship types in this design, we can see that they all have a degree of 2. Okay, so they all have 2 legs, no more than 2, only 2 legs. Okay. And the next step, basically, we're going to discuss how we're going to identify the constraints of the relationship type. So recall that in the ER design, when we capture a relationship type, we have to supply the constraints for that relationship type. So the constraint basically measure how each entity participates in that relation. Okay, so here I think this basically discuss the differences between the relationship type and relationship set. So relationship type is considered as the schema description of a relation. So it's identify the relation of the same type, and also it's kind of also it identify the certain relationship constraint. So we're going to discuss it. So in the ER design, we only need to capture the relationship type. So relationship type pretty much can be considered as identified by a name. So whatever name we put in the diamond box, and its constraint. So in this design, we haven't supplied the constraints for each relationship type yet, but we're going to do that. Okay, so that's the 2 key components of a relationship type: the name of the relationship type and the constraints. Okay, so, oh, sorry, I forgot to mention the relationship set. The relationship set identifies the current set of relationship instances in a database. So each relationship instance actually relates individual entities kind of from the participating entity types. So one from each participating entity type. Okay, so pretty much for the binary relationship type. Okay, so this is all the binary relationship type. A relationship instance only relates 2 entities, one from each participating entity type. For example, let's say an employee manages department. So if an employee is manager, then we're going to have a one managers relationship instance. It relates one employee as a manager and the corresponding department. Okay, so then for the works for relationship instance, it also relates two entities, one from employee, one from department, but the semantics here is a little bit different from managers. So that's basically relates an employee with the department that employee works for. The managers actually relates an employee with a department that employee manages, okay? So each relationship instance only contains, for the binary relationship type, only contains two entities, or only relates two entities, one from each participating entity type. Okay, so that's kind of the thing you need to be aware of. Now this figure simply shows kind of a, we call the coordinate ratios, or sometimes we also call like the maximum number of the relationship instance an entity can participate. Okay, so let's first introduce this N1. So N stands for multiple, 1 stands only one. Okay, so we put 1 on the right side. So this works for is a relationship type, and employee, we have employee entity set, we have department entity set, and each, kind of solid square or rectangle box indicate a relationship instance. Okay, so for example, R1 relates to E1 and D1. So relates, that means that E1 works for the department D1. Okay, R2 relates to E2 and D2. The semantics here is that employee E2 works for department D2. Okay, so then you can tell that for the same department, they may have multiple employees working for it. So for example, D1 in this case has related to 3 relationship instances. So what the line connecting to, each line connecting to D1 indicate a relationship instance. Okay, so in this case, D1 participates in 3 different relationship instances, one for E1, one with E2, and one with E6. Okay, so now you may be able to guess what does this one mean. So this one basically is a constraint. So it restricts that an employee can only relate to one department, okay? Or an employee can only participate in one relationship instance. This relationship is called works for. Okay, so this really kind of constraint depending on the business requirement. Maybe like EULAR, we may have some joint kind of a joint position. So a faculty may belong, we can like devote half time for one department and another half time for the other department. Okay, so in this case, that means that an employee can work for 2 departments. Okay, but in this example, if we put 1 here on the department side, that indicates an employee can only work for 1 department, no more. So that's more like a business constraint. Okay, so if you examine every employee kind of entity here, you can tell that each one of them only relates to 1 department. So that's the one means. The N actually used to describe that how many relationship instances a department can participate. So N means multiple. So that means that a department can relate to multiple employees through this work for relationship. So then the semantics can be like this one. So means that a department can have multiple employees working for it. Okay, so for example, if a department has 10 employees, then that department will participate in 10 works for relationship instance, one with each employee. Okay. So now I think the thing is that you cannot switch the position of one and because if you switch it, then the semantics is totally different. So this one used to explain that for an employee, how many departments an employee can work for. So one means only one, okay? So it's more like when you have that number, you have to explain. It's actually that number used to explain how many relationship instances the entities on the other side participating. Okay, so this one basically we have to go to the entity tab on the opposite side. So it's describe that how many relationship instances a department can participate in. So M is multiple. So this multiple usually indicate a department can relate to multiple employees, or a department can have multiple employees working for it based on the semantics of the relationship type. Okay, questions? Let's look at this one. This stands for works on, so employee works on project. So both N and M both indicate multiple, more than one. Okay, so M used to describe that given an employee, it may work, that employee may work on multiple projects. Okay, M means multiple. So describe that the maximum number of the relationship instance an employee can participate. Okay, so this N used to specify the maximum number of the relationship instance that a project can participate. So this N can be translated as a project can have more than one employees working on it, or a project can have multiple employees working on it. Excuse me. So this N, M, simply just representing the maximum number of the relationship instance an entity can participate in. So once again, the location of N and M are very important. So we always interpret a number by the entities on the opposite side. Okay, so when we interpret N, we have to go to the project, the entity tab on the opposite side, the project. It describes that a project can have multiple employees working on it. So it means that a project can participate multiple relationship instances. So this multiple relationship instances all share the same project but relates to different employees. So that really indicates a project can have multiple employees working on it. Okay, this M used to describe that an employee can participate multiple relationship instances. So that means that an employee can work on multiple projects. Okay, so that's kind of those notations. So once again, so those numbers we can only have two possible numbers, one or N. But one in a situation that like this one is called multiple to multiple. Okay, so instead of have two N, we just replace one N as M. But in essence, both N and M representing the same thing, multiple. Okay, so this is called cardinal ratios. So this means that many to one. So the cardinal ratio for the work sum is many to one, and the cardinal ratios for work sum is many to many. Okay, so these numbers really indicate the cardinal ratio. So when we're talking about a ratio, we have to have two numbers. Okay, so that's how we represent it. Okay, I think, let me see. Yeah, I think we discussed the degree of a relationship type. So the degree of a relationship type simply means how many connections coming from that relationship type. Okay, so most of the time that means how many entity types that relationship type relates to. But for the recursive, basically, although recursive correlates to the same entity type, but it's twice. So that's why recursive relationship type also considered as binary. Okay. So in this, I think in majority of the design problem, we probably will mainly focus on the binary relationship type, means that a relationship type only has two connections, either to the two different entity types or to the same entity types. Okay. But sometimes in some design, we do have like a degree more than two, like a ternary. So let's see the example here. So this preferences, the degree of the preferences is actually 3 because it has 3 legs, 3 connections, okay? So it's actually connected to the bars, drinkers, and the beers. So it's actually described that for a specific drinker, given a specific bar, that drinker will have a preferred beers. So if the same drinker go to different bars, then he may have different preferences. Okay, so that's kind of this preferences really describe the relationship between the drinker, bar, and the beers. Okay, questions? So this called ternary relationship type. So the degree of the relationship type is very simple, just simply the number of the connections that coming from that relationship type. So we simply count the legs. Okay, so those number of legs indicate the degree of the relationship type. So I think we discussed that already. So for the recursive relationship type, so this supervised, its degree is still 2 because it has 2 legs. The only difference is that we call it recursive because both legs are connecting to the same entity type. So in order to distinguish how an employee participates in this relationship type, we actually supply a role name for each participation or each leg. So that's very important. Role names are very important, okay? So let's discuss the, I think that's the what we end up with the draft 1. Just, with draft 1. And let me see what else. Okay, I think we does discuss the constraint like coordinator ratios, like those numbers, and then remove redundancy. So we want to our design is concise and not contain any redundant information. So that's kind of the consider a good design. So you don't want to contain the redundant information because redundant means that you do not need them. But if put them into design, it may cause confusion or at least make your design is not that concise or simple. Okay, so here what we mean the redundancy here is that recall that each employee have a department, right? So we kind of refine this department into a relationship works for. So through this works for relationship, given an employee, we are able to retrieve his or her department. You understand? So in this case, maintaining both works for relationship and the department attribute considered redundant because department attribute of the employee really describe which department an employee works for. And this works for relationship also describe which department an employee works for. So in this case, we basically consider department attribute is redundant. So that's why we can remove the department in order to reduce the redundancy. Okay, so that's kind of practice. So it means that if we have an attribute and the relationship type, they pretty much represent the same thing, then we will keep the relationship type and remove the attributes. You may ask why. I think because through this diagrammatic notation, when we have this works for connecting to the employee and the department, then the semantics here is very, I think it's very clear. Means that we capture which department an employee works for. Then as a department attribute for the employee, so sometimes it may be confusing. It means the department that employee works for, or the department that employee manages, or the department of the project that employee works for. You understand me? So that's why if an attribute and relationship both representing the same thing, then we would rather keep the relationship tab, remove the attributes, because the relationship tab, the semantics is very clear, and also it's very easy to understand by the user who even do not know much about the ER diagram. They can pretty much understand the meaning. Okay, so that's why the department is considered redundant. We're going to remove it. Okay, then another one is supervisor. Okay, so supervisor is an attribute, and this supervise relationship tab also capture given an employee who is his or her supervisor. So in this case, both representing the same thing, we're going to refine by removing the supervisor attribute from the employee. Okay, and I think another thing is that like a department, controlling department of the project. Okay, so we have also controls relationship, department controls project. So in this case, controlling department we can remove because it's considered as redundant. It has the same meaning as the controls relationship type. So that's why we're going to remove the controlling department, because that's considered as redundancy. Okay. Then another one, I think we kind of be careful. Let me see if we have good. Let me see if I have good. Okay. So doesn't matter. So this E name, I think original design we kind of store the employee. So this employee is represented by the employee name. So in this case, this employee name identify who, kind of which employee a dependent kind of associated with. Then this dependent of relationship type also describe the relationship between a dependent and his or her corresponding employee. So in this case, we can remove the E name because that's considered as redundant. The last one, not last one, the managers of the department, the same thing. So manager and the manager's relationship, they're all trying to identify who is the manager of a department. So that's why we can remove the manager attribute from the department. So here, basically, we follow the rules that if an attribute and a relationship tab representing the same information, we will keep relationship tab, but we will remove that attribute. Okay. I think last one is the worksum. So for the employee, we have worksum, and worksum has two components: project and hours. Okay, so worksum contains project. It describes that which project an employee works on. So that's why the worksum relationship can be used to replace the project info, that attribute in the employee. But worksum also has hours. Okay, so these hours actually apply to each individual project that an employee works on. Okay, so then if we put hours on the employee side, we remove the project, then it's pretty it's pretty messy. So it means that we keep a bunch of hours because we remove the project due to this worksum relationship. We keep a lot of hours, but we have no relationship between the hours and the corresponding project. Okay, so that's considered it's not good design for keeping the hours as an attribute of the employee. Even we can keep it as multi-values because an employee can work on multiple projects, but still not consider a good way to capture, because we did lose the relationship between an hour and corresponding project. The same thing if we put hours onto the project side, for example, that also will be multi-valued. Why? Because a project may have multiple employees working on it. Okay, so then that multiple hours also lose the connection with employee. So we don't know which hour is for which employee on that project. So the best position will be we put hours onto the worksum, the relationship type. Okay, so a relationship type can carry attributes like an entity type. But the nice thing about a relationship type attribute is that that attribute will apply to each relationship instance. Okay, so it means that each relationship instance will have that attribute value. For example, if we put hours to the worksum as attribute of the worksum, then for every relationship instance, that worksum will have a value. So then the semantics is very clear, because each worksum relationship instance relates one employee with one project. Then that hours, the semantics really clear, that record the number of project hours for that employee for a given project. Okay, for example, if an employee works on like 3 projects, different projects, then that employee will participate in this worksum 3 times. So each time represented by a relationship instance. Then each relationship instance will be carrying an hour. Okay, the same thing if a project has 10 different employees working on it, then that project will participate worksum 10 times, 1 for each employee. Then each relationship instance will have hours, our attribute or our value. So that's really can accurately capture the number of hours of a particular project by a specific employee. Okay, so that's kind of a, so here we just discuss how to remove the redundant attributes. So that's kind of how we remove supervisor, manager, controlling department, e-name, and worksum department and supervisor. Okay, so then at this moment, when we identify the primary key for each entity type, I think for the employee, it's very obvious SSN can be a good ID for each employee. Then the department name can be a good ID serving to uniquely identify each department. The project, same thing, the project number. Then once we come to the dependent, okay, so we only, since the e-name is removed, so we only have name, sex, birth date, and the relationship. Okay, so now it's possible, not always, but it's possible that we may have two dependents. They have the same name, they have same gender, sex, they have same birth date, they have same relationship. So I think this will be very rare, but it's not impossible. Okay, so that basically means that at this moment, we will not, even we use all 4 attributes, we will not guarantee to uniquely identify each dependent. Okay, because if for some reason we do have two, if just by coincidence we do have dependents have the same name, sex, birth date, and relationship, then we will have trouble. Okay, so now the dependent will be considered as a weak entity type. I don't know if you remember that we do discuss weak. So that's basically what I mean here. So then the dependent may have to be refined into a weak entity type. Okay, so now for the weak entity type, we do have a special notation for it. So we're going to use double boxes to represent a weak entity type. Okay, so the non-weak entity type, sometimes we call the normal weak entity type or strong weak entity type. We only use single box. We kind of reserve this double box only for the weak entity type. Okay, and for the weak entity type, we basically, how do we identify each weak entity? Okay, So we're going to use its owner's owner's primary key. So what the owner of the dependent. So in this case, the employee is considered as owner. Why? Because I think we can consider that each dependent, they can only exist if they're related to an employee with them. Okay. And then I think another thing we can consider as the owner is that because when we remove the e-name, so e-name stands for the employee. Okay. So that's kind of a means that the employee is owner of the dependent. Okay. So then, in order to uniquely identify its dependent, we have to use its owner's primary key, that will be SSN, plus some attributes in the dependent to uniquely identify each dependent. I think with the SSN of an employee, then we assume that each employee, his or her dependents, regardless if she has only one or multiple, we assume that each dependent of an employee should have a unique name. So that means that using the employee's SSN plus dependent name info, then we're able to uniquely identify each dependent. Okay, so then we're going to underline the name, but in a dashed underline, not solid underline. So this dashed underline indicate partial key. Okay, so that means that this name by itself is not a key, but partial key only exists for the weak entity type. Okay, so partial key plus its owner's primary key together can be used to uniquely identify each entity of the weak entity type. Okay, then we use this double diamond to represent a relationship between a weak entity type with its owner's entity type. Okay, so double diamond box only for the relationship between the owner and weak entity type. So in practice, a weak entity type may also relate to other entity types. So that's fine. But for those relationship type, we still use single diamond box. We only use double diamond box for the relationship type between the owner and the weak entity type. Okay, so owner entity type and the weak entity type. So this double diamond box is called identifying relationship type. Means that it's used to identify the owner's entity type of a weak entity type. Relationship type, not entity type. Okay, so this double diamond indicate identifying relationship type. Okay. Okay, now we kind of further discuss the coordinate ratios. So that's what we mean here, the numbers we put on the side of a relationship type. So there are only 3 possible coordinate ratios: 1-to-1, 1-to-n, or many-to-many. Okay, 1-to-many, many-to-1 are considered the same, and then many-to-many. Okay, so for the many-to-many, we usually use n to m. We do not use n to m. Okay, just trying to distinguish them. Okay. So now let's see the kind of we need to, in the design, now we have to supply the constraints, so relationship constraints for each relationship type. So let me first get my So here, when we're talking about the relationship type constraint, come on. We have to refer to the data description. Let me see if you're able to view it correct. Yeah, I think you're able to view it clearly. So that's kind of the design. So in our design, once we end up, we kind of sketch all the entity types and the relationship types. Then last task, we need to specify the relationship type constraints. So we're going to discuss two ways. One is called using the coordinate ratios and participation constraints. The other one is using the minimum maximum. I think that's probably you guys are familiar with. So it's very similar to the UML notation, okay? So let's first start with this one. So then in order to determine the coordinate ratios, very often we have to refer to the data description, because like I said, that coordinate ratios, a lot of them really are dependent on the business rules, okay? So for example, employee managed department. So when we supply the coordinate ratios, we have to rate carefully about, for example, how the department manager is described in the data description. So let's say that for the company organized in departments, each department has a name, number, and an employee who manages the department. So that means that a department has only one manager, because maybe each company is different. Some company only has one department manager, some may have multiple, right? So according to the data description, since each department has only one manager, so that means that a department can relate to only one employee as a manager. So we put one on the employee side. So we interpret this one from the other side. So means that it describes that what are the maximum number of the employees can manage the department. So according to the data description, one, we put one here. So it's interpreted as a department is managed by one employee, maximum one employee, or only one employee, okay? Then regarding to employee managed department, I think we have only two possibilities, either one or many. So one means that an employee manages only one department. If we put n, that's a different story. That means that an employee may manage multiple different departments, okay? So here, it doesn't show any information about how many departments an employee can manage, or an employee can be the department manager. Then I think we can make assumption, or I mean, usually I think an employee is supposed only manage one department. So then we put one on here too. So we put one here. So this one really indicates an employee can manage only one department. Okay, so there's only one relationship instance an employee can participate. So these coordinate ratios actually representing the maximum number. Okay, so maximum number department an employee can manage is one. Okay. But I want to let you know that it will be a good practice that when you determine the coordinate ratios, if you're not able to infer those information from the data description, it will be always good you write an application, you write kind of an assumption list, because those assumptions are made by you and those information cannot be found in the data description. So once you finished your design, you have to go to your client who you design a database for, then you have to validate those assumptions, because when the user write down the data description, they may not be that comprehensive. They may miss some information. So you have to go to them to validate those assumptions so that they can evaluate if your assumption is right or not. If your assumption is not right, then you have to revise your design accordingly. Okay. Okay, let's go to the department controls project. So we have to determine, for example, how many projects, the maximum number of projects a department can control. Okay, and this number indicates, given the project, the maximum number of the department you control that project. So let's go back to the data description about project. So each department controls a number of projects. So that's really indicate, given a department, we can have multiple projects that controlled by that department. So that will be the maximum number. Okay. Use the change the color, and maybe also change the font. How come here? Okay. So this N really indicates a department can control more than one project. So its maximum number of projects can control is more than one. Okay. Then regarding to how many department can control a project. So a project can be controlled by a single department or can be controlled by multiple departments. So now we do not have any information about whether a project can be controlled by only one department or can be multiple departments. So in practice, both are reasonable. Maybe a project, some company may require a project that's within the department, but some projects may be the collaborated project. I think this may be controlled or involved by multiple departments. Then depending on the involvement, maybe they only select one department as the controlling department. But anyway, we don't know what's the really the business rules in that company. So then here you can basically put whatever you want. Okay, so then you have to give the corresponding, because you're not able to inform whether there's only one controlling department or multiple controlling department. Okay. So that's why here, for example, I put 1. So that means that I assume that there's only one, each project has only one controlling department, but we have to write down our assumption. Okay. So now we have to record our assumptions we have. Sorry, I don't want to be this. Yeah. I think I'm able to view it clearly. So let me shrink it a little bit more. So assumption 1, each project can be controlled by only one department. Okay, so this is kind of an assumption we can put here. We always need to record our assumption so that we can go back to the client to validate if our assumption is right or not. Okay, so that's, I probably can further. Yeah, I think you're still able to view it. Okay, so this assumption corresponding to this one. So if you make a different assumption that each project can be controlled by multiple departments, then you put an M here, but you have to have the corresponding assumption. Okay, so consistent. Okay, so that's why in your design, I may say different constraints. I mean, from different students, that's fine. But as long as you have your assumption and your design is consistent with your assumptions, then that will be fine. Okay. Okay, let's go to the next one. Employee works on project. Okay. So I think according to the description of the employee, an employee works for one department but may work on several projects. So that means that we can put N on the project side, indicate, sorry. So this indicate that this N indicate an employee can work on multiple projects. Okay. Then we have to put a number on this side. So this number really describe a project can have a single employee or can have multiple employees working on it. Okay. So I hope you know the semantics. This N indicates an employee can work on multiple projects, many projects. But it will participate one relationship instance with one project. Okay, so if an employee, like I said earlier, works on like 3 different projects, then this N indicate is right, means multiple. And then the employee will participate this works on in 3 times. So participate in 3 relationship instance. And then each relationship instance only relates that employee with a specific project. Okay, I think for this one, you may also works on should also have attributes. These attributes should be hours, I think. Okay, so I think the right one should be the works on has an attribute hours. Okay, so then if employee works on 3 projects, these hours will be applied to each relationship instance. So we're going to record 3 hours, one for each relationship instance. So now we still have the number on the employee side. So maybe I put it a little bit higher. So okay, so I think this hour should be in the single quotes. Now we have to determine the number on the employee side. So this number really restrict, given a project, how many employees can work on that project. So maximum number of the employee can work on the same project. So I think there's no description in this data description. We cannot infer from the data description. Then we can give, I think there's only 2 possible values, 1 or n, so multiple. So personally, I think I want to give it multiple. So that means that a project can have multiple employees working on it. Now we have 2n, so usually we remove, kind of revise or replace the n with m. So just simply just to distinguish, we don't want to have 2n, so we use 1n, 1m. So m and n basically representing the same thing, okay? So then I need to add the assumption here, means that each project can have multiple employees working on it. Okay, so that's how we write this assumption. Okay. So that's pretty much about coordinate ratios. I think we should have some more, but we don't show here. Okay. So coordinate ratios, just the one type of constraint used to describe a relationship type. So I think the most important thing for you to understand is that first, how to determine those two numbers. Okay. Second one, if you have make your own assumption in order to determine the coordinate ratios, you have to record your assumptions because you have to validate those assumptions with the end users who are the users of this database. Okay. So then there's one more thing called participation constraints. So I think if you recall that when I call these coordinate ratios, each number I actually set the maximum number of relationship instances entity can participate in, or for example, the number of the projects an employee can work on, or the number of the controlling department a project can have. So this is a maximum number, okay? Then the participation constraint basically describe the minimum number of the participation or minimum number of the relationship instance that an entity can have, okay? So there are only two types of the participation constraints, partial versus total. Partial basically means that an employee may not participate in the relationship. Okay, so in other words, if we look at let me see. For example, let's see this one for the managers. So 1 means maximum. Then the minimum can be minimum can be 0 or 1. So 0 means partial, 1 means total. So what does 0 mean? For example, if you look at the employees, for those employees and this relationship managers, so we can tell that not every employee needs to participate in this manager's relationship. Okay, why? Because only a few employees will be the manager. The remaining non-manager employees will not participate in these managers. So in this case, we consider employees' participation is partial. By partial, we mean that only some employees participate in this manager's relationship, and some employees will not. Okay, so only some, not all of them. Okay, so then we can probably interpret as a minimum. So minimum means that given this manager's relationship, what's the minimum relationship instance an employee can participate? I think if that employee is not manager, then his participation will be 0. So maximum number of the relationship instance, the manager's relationship instance an employee can participate will be 0. Okay, those 0 means for those non-managers. So in this case, we consider employee as partial because not everyone participates in this one, managers. And for the department, that's a different story. So for the department, it means that we assume that every department must have a manager. So that means that every department must participate in this manager's relationship in order to release its corresponding manager. So that's why the department participation will be total. So partial, total. So for the total, we're going to use double line connecting the relationship with this entity type, with department. So we use first line, second line. So this double line indicate the total, and this single line indicates the partial. Okay, so partial means what? Partial means that not every employee participates in these managers. Total means that every department must participate in the managers. Okay, so I think we discussed a lot concept. I want to stop here. So next class we're going to finish the participation constraints. Basically, I think we already finished. We're going to practice the both coordinate ratios, numbers, and double line, single line participation constraints. And then I think we also discussed another notation very similar to the URL notation. So then I think we are done with the ER design. So I think we may work on 102 in-class exercise to show you how to design an ER diagram. Then you will have one ER design assignment. Then that's it. Okay. Any questions? Okay, if you do not have any questions, we are done for today. Thank you.